Creating satisfying game feedback is all about visual clarity, and few things require more clarity than ability cooldowns. So today, we're looking at how to build a hotbar cooldown effect from scratch in Godot. I just recently implemented this cooldown shader in one of my prototype projects, and so here's how I did it. Before we jump into the code, let's take a quick look at the scene tree. First, you can ignore all of these labels for now. They're just here to show the text on the screen that you see in the demo. We'll assign values to them later. The most important parts of the scene are these color rect nodes. These three nodes are where the shader material will be applied, and where the final icons will be displayed on screen. You could use other nodes instead, like a texture rect or even sprites, but for simplicity, I went with these color rect nodes. The only downside I found was that these don't have a starting width or height. So in order to ensure that the images are the correct size in a grid, I had to set custom minimum size on the nodes in the inspector. In this case, I've assigned each icon to be a 100 by 100 square. These nodes are stored inside of a grid container, just to make them easier to align the abilities and labels into rows. Your project probably has its own way of organizing and showing the hotbar or the input UI. Okay, now that we know where the images are going to show up, let's jump into the code. We'll be using two different scripts, each serving a different purpose. One for the shader code, written in the Godot shader language, and one written in GDScript to configure the shader, handle the player inputs, and keep track of the current cooldowns. First, let's look at the shader code. This is written in the Godot custom shader language, and so we'll have a file with the .gdshader extension. It's a 2D canvas shader that indicates the cooldown progress directly on top of the ability icon. It's designed to make it visually clear whether an ability is ready to use, currently on cooldown, or somewhere in between. There are a few important parameter uniforms that you can set from GDScript or in the inspector. First, we'll have the custom texture. It's the main texture for the icon. The shader will surround the icon with a border. The cooldown progress is the primary control setting, a decimal number between 0 and 100, representing how far along the cooldown is. We should consider normalizing this to go from 0 to 1 later, but to make it easier to follow, I'm just using the percentage format. When it's at 100%, the ability is ready to be used. When it's at 0, the cooldown was just started. The active color and cooldown colors are used to define the border color, for when the ability is ready and for when it's not. And finally, there's the border size value that lets us define how thick the outer edge should be as a portion of the total area. With those values in mind, let's see how the magic works in the fragment function, where we'll execute the logic for each pixel in the image. First, the shader splits its work and the image into two zones, the border zone and the main texture area. If the current pixel is inside the border zone, meaning it's close enough to the outer edge, the shader will either show the active color or the cooldown color depending on if the ability is ready or not. The size of the border zone can be adjusted using an input uniform. This represents how thick the outer edge should be. It's in UV space, so the value is usually pretty small to represent a thin border around the icon. You can increase or decrease this to make the border meet your needs. And we'll take that a step further. When the ability is on cooldown, we apply a radial sweep effect that rotates clockwise. This is done by using the arctan function to calculate the angle from the center of the image to the pixel. If that angle falls within the current cooldown progress, we slightly darken that part of the border, giving the illusion of a circular sweep that draws the border in two colors over time. Now, for the pixels inside the center of the icon, we're just going to draw the main texture as usual, sampling the custom texture using the texture function. But if the ability is on cooldown, we'll layer on two extra effects. First, we reduce the brightness of the icon, and second, we convert the colors to a grayscale. This helps visually reinforce that the ability is temporarily unavailable while on cooldown. And that's the shader code. It handles drawing the icons, but it doesn't handle any of the timing logic. We get a border that'll change colors as the progress sweeps from 0 to 100, and the main ability texture will get a visual dimming effect when the ability is on cooldown, all tied to that single progress variable that we can update from code or in the inspector. Now that we know how the shader draws to the screen and how it's configured, let's look at the GDScript code that sends values into the material. It handles the input key presses from the player, initiates and activates the cooldowns, and sends the current progress percentage into each of the shaders so that they'll be updated and redrawn in real time for each frame. I configured the input map to have 3 different abilities, which are activated using the number keys 1, 2, and 3, much like you'd see in an MMO-style hotbar. Like the UI, you probably have different ways to handle input in your games, and so this could be handled other ways, but for simplicity I've hard-coded it to just these 3 actions. Each action can be configured with its own cooldown timer. How long will the cooldown last when the ability is used? To demonstrate, we have these abilities set to 10 seconds, 7 seconds, and 2.5 seconds. The next 6 variables are internal values that keep track of when the abilities are on cooldown and how far along they are in the cooldown. The 3 Boolean values are automatically set to true while the cooldown is in effect, preventing the player from using the ability again. They'll be set back to false when the cooldown expires. And these 3 remaining float variables hold the percentage completion for each of the cooldowns. These values will automatically update as the progress goes from 0 for just activated to 100 for cooldown completed. They're the primary values that we'll send into the shaders so that the shaders know how to draw the icons as the cooldown runs. Now, let's look at the ready and process functions. The ready function, that runs once when the scene is loaded, isn't really necessary for the cooldowns to work. But because our cooldown timers are hard-coded in the variables above, we'll use it to set some label text, to show the max cooldown for each ability. The process function, that runs for each game frame, is where the main input handling and cooldown timing logic is located. We'll look at the check cooldown function in a second. Below that function is where we'll update more of the labels during each tick of the game clock. This time we're setting the labels to display the cooldown percentage for each ability. You'll see those labels go from 0% to 100% as the cooldown runs. Okay, back to the check cooldown function. For every process frame, Godot will run this function to do 2 things. First, it updates the current shader progress for each ability so they know what to draw. To do that, we pass the 3 cooldown percentages into the shader materials as parameters. And second, it checks to see if the player just pressed the 1, 2, or 3 keys. If they did, and the ability is not already on cooldown, it'll proceed into the appropriate activation function for that ability. That means we'll have 3 activation functions, but they're basically all the same steps. Each activation function will first print out some debug. That's probably where you'd put your code to resolve your ability, like firing a missile or casting a spell. I just went with print statements to make it easier to demonstrate. Then the function continues with the cooldown logic. It sets the active flag for the ability to true, telling the game that the cooldown is now in effect. And it sets the cooldown percentage to 0, representing an ability that was just activated. Once it makes those changes to block player input, it sets up our tweens. This is the main timer logic and how we'll manage the progression of the clock from 0 cooldown to 100 cooldown. It uses property tweens, and they'll make the given variable, in this case the cooldown percentage for the ability, go from 0 to 100 over the specified amount of time. That way, the new values will be picked up during each frame, giving us the cooldown animation. The last thing these activation functions do is connect the tweens finished signal back to this calling script. With the signals connected, when the tween is finished, it'll call the appropriate callback function below. The last 3 functions in the script are those callback functions. These represent the moment when the ability has left cooldown. Their primary responsibility is to set the active flag for the cooldown back to false, so that the player can once again activate the ability with a key press. And like the activation functions, this is where you could perform any actions you want during the finish signal, like playing a unique sound or shaking the screen. Like before, I'm just using print statements to show the logic is working. And now that we have everything in place, we can run the project and test out the key press and cooldowns. Each cooldown is handled separately. Each image reflects the current state of that cooldown, if any, and we can replace the print statements with actual code that does stuff when the abilities are activated and when they finish. Pretty neat, huh? I'm sure there are a bunch of ways to improve a system like this, but it's a quick and easy solution to a common game mechanic, and I hope you found it useful. You can find the code for this shader on our GitHub page, and if you have questions or suggestions, send them my way. Thanks for watching the Pathfinder's Codex.